Okay, on this problem, you're asked to find the length of the curve x equals y cubed over 15 plus 5 over 4y on the interval from 3 to 5. Now, from this section, you learned that the length of the arc length of a curve can be found using this formula, the integral from a to b, square root of 1 plus the derivative of your function with respect to your variable. So in this case, it's going to be dx dy. You're going to square that, and then with respect to y. So let's just rewrite this function so finding its derivative is a little bit easier. Y cubed over 15, that's not going to be a problem. Sometimes I encourage students to write this as 5/4 y to the negative 1, so that they can then see that the derivative of x with respect to y, just using the power rule here, the 3 will come in front, so this will be 3/15 y squared because you reduce your exponent by 1, and then here this will be the negative 1 will come in front, so this will be minus 5/4 y to the negative 1 minus 1, which is negative 2. So you can clean this up a little bit. 3 goes into 15 5 times, so you can write that as y squared over 5 minus 5 over 4y squared. And then you could just plug this in to that equation. Let me get some more room here. So you would say, okay, L then is going to be the integral from 3 to 5 of the square root of 1 plus this derivative that we just found, which is y squared over 5 minus 5 over 4y squared dy. And this is actually a fun problem to integrate, and I'll show you the algebra to integrate this. But if you want only to look at the first couple of minutes of this video, because they just want a decimal approximation, I will show you that you can either use Wolfram Alpha. Notice I even typed the word integrate wrong, but I went to wolframalpha.com and I just typed in, kind of pay attention to my parentheses here. Notice this whole thing is a set of parentheses and then squared, and then the parentheses there saying that I want to integrate that to the 1/2 power, which would do the square root, and then I tell it from 3 to 5. And then it did correctly know what I wanted, and it gave me the answer. Now that's a nice answer, so that tells you that this could be done by hand. I can also do it kind of with my old calculator. I took a photo of how I have it typed in here so that you could see, you can use your square root, and you have to be careful in this denominator here because you're dividing by 4x squared. You have to put that in parentheses. On this calculator, I have to use x instead of y because it doesn't understand that. But let's say if we wanted to do it by hand for fun, so obviously you could stop the video now if you don't want to see some fun algebra. The first thing you're going to have to do is play with this function, the square root of, or this expression 1 plus, and then it was going back up here, y squared over 5 minus y squared over 5 minus 5 over 4y squared, and that whole thing is squared. Let's just play with that. Let's just see how we can simplify that. Okay, now the first thing that I would do is get a common denominator in here, and the way you would do that is you would multiply by the LCD, which is going to be 20y squared. So on this side, that's just the product. If you multiply by 20y squared over 20y squared, and on this one you would multiply by 20y squared over 20y squared. So you just multiply top and bottom of each term by the LCD. You'll see that this is really, 5 goes into 24 times, so this is going to be just 4y to the 4th there, and 4y squared goes into 20y squared 5 times. So you end up with the square root of 1 plus, and then in this part you're going to have 4y to the 4th minus, so this 4y squared goes into 20y squared 5 times, so minus 25 all over the common denominator that you just looked at, which is the 20y squared, and that whole thing is squared. Okay, so you have to FOIL that out, so you'll have the square root of 1 plus, this will be 4y squared, which is 16y to the 8th. Remember, you're going to do 4y to the 4th minus 25 times 4y to the 4th minus 25. So you will FOIL this out. You know, here is 16y to the 8th, and etc. So 4y to the 4th minus 25, that's 100. And you have that twice, so that's going to be minus 200y to the 4th, and then plus 625. And that's all over 20 squared, which is 400y to the 4th. And now you have to repeat this process of getting the common denominator. So you're going to want to get a common denominator here, so we'll multiply this by 400y to the 4th over 400y to the 4th. Just thinking of 1 in the form of 400y to the 4th over 400y to the 4th. So this is the square root of 400y to the 4th plus 16y to the 8th minus 200y to the 4th plus 625, all divided by 400y to the 4th. And then you can clean this up. You can collect like terms here, and you'll have the square root of 16y to the 8th plus 200y to the 4th plus 625 divided by 400y to the 4th. And this is really cute because this numerator, this top, is actually a perfect square. It factors as 4y to the 4th plus 25 quantity squared. And so that, you know, it's a kind of a cute little problem, maybe, if you guys are into this stuff. So 4y to the 4th plus 25 quantity squared over 400y to the 4th. And now you can take the square root of the top and the square root of the denominator. So the square root of this, of course, is just going to be that stuff. And the square root of this is just going to be, you know, easily that'll be 20y squared. So back to our integral now, we'll have the integral from 3 to 5 of the square root of the numerator, which is just going to be 4y to the 4th plus 25 divided by the denominator, the square root of the denominator, which was 20y squared dy. Now this is not such a bad integral problem. When you're dividing by a monomial, a single term in the denominator, you want to split that up. So we'll think of this as the integral from 3 to 5 of 4y to the 4th divided by 20y squared plus 25 divided by 20y squared dy. Then we can simplify that, the integral from 3 to 5 of, this will be 1/5 y squared plus 5 over 4y squared dy. Okay, and now we can just go ahead and use the power rule to integrate this. You add one, recognizing you do want to recognize that you can think of this as 5/4 y to the -2. So do remember that. So now when I go ahead and integrate, this will be 1/5 y to the 3rd over 3. Now when I add 1 to the exponent here, it's going to be -1. So it's going to be minus 5/4 y to the -1. And we're going to evaluate that from 3 to 5. So I'll clean that up a little bit. This is going to be 1/15 y cubed minus 5 over 4y evaluated from 3 to 5. So now you can plug the 5 in, and you'll get 1/15 times 5 cubed minus 5 over 4 times 5 minus, when you plug 3 in, you'll get 1/15 times 3 cubed minus 5 over 4 times 3. And I guess I got a little bit of time so I can do all the math here. This 15 is 5 times 3, so you can cancel one of those 5. So you're going to get 25 thirds minus, the 5's cancel there, so that'll be 1/4. Minus here, this is 5 times 3 again, so remember you can cancel the 3 now, and so this will be 9/5 minus, can't do anything with that, 5/12. Okay, and so you can get a common denominator here of 12. So this will be, multiply this by 4 over 4, so this will be 100 twelfths minus 3 twelfths minus, this would be 60 will be your common denominator, so you're going to have to do 12 times 9, which is 108 twelfths minus, this will be 25, not 12, sorry, 60th, and this will be 25 60ths. I'm doing this all in my head on a Saturday morning. Let's see how it goes. 100 minus 3 is 97 twelfths. And then minus 108 minus 5 is going to be, sorry, minus 25. I have a 3 there, and so that's going to be 70. No, I'm doing awesome here. So this is 83, right? 83 plus 25 is going to be 108. Okay, very impressive. So 83 over 60. And then let's get a common denominator here. So multiply that by 5 over 5. So 97 times 5, 45, 485 over 60. So 485 over 60 minus 83 over 60. And that will be 402 over 60. At any point, you probably would have done a calculator, and I hope I haven't made a mistake to ruin this whole video. 402 over 60. And let's see, 2 will go into that. 201 over 30. And I'm feeling pretty good. So 30 into 201. So let's try 6. So that'll be 180. And then we'll get, let's see, this when we subtract here, this will be 1, and this will be 2, and this will be a 0, and there you go, 6.7. So both with the calculator and old school in 12 minutes on a snowy day in Nebraska.